Okay, so the most general thing we can do here is we can look at the area between two functions, or region bounded between two functions, between x equal to a and x equal to b. So something like this. This is going to be a little bit different from what we've already been doing, but not really crazy, and it's really similar to a lot of the ideas we've already been looking at in the previous section and the section before on washers and on areas between curves. So what's the deal here? Let's take what happens when we rotate this around the y-axis? Well, we're still going to get a bunch of cylindrical shells, and the question is, what is going to be the surface area? To figure out the surface area, we just have to figure out for some value x with function value f of x and g of x here and here, what is going to be the radius, what is going to be the height. Well, the radius, we're always going to be rotating around the y-axis. We could do more general things, but I'm just trying to make life easier for us. So the radius is still going to be r. Well, what's the height going to be? The height is the difference in the y-coordinates between this point up here and this point down here. So the height, and that's supposed to be an h and not a u, h is equal to f of x minus g of x. So that means that our volume is going to be the integral from a to b of 2 pi x times f of x minus g of x dx. Okay, so let's find the volume of this region rotated around the y-axis. The region is between x equal to 0 and x equal to 3, and the functions, or the graphs of the functions, the square root of x squared plus 1 and 1 over x squared plus 1. Alright, so the volume is going to be the integral from a to b, which is from 0 to 3, of 2 pi x. That's really 2 pi times the radius of a cylinder, times the height of the cylinder, which is the difference of the function values, root x squared plus 1 minus 1 over x squared plus 1 dx. Now, I really set this up so that I could do a substitution, but one that'll work kind of quickly. U is going to be x squared plus 1 because I see it underneath the radical. Generally, you see a function under a radical. Let u be that function. So du is going to be 2x dx. That's going to work nicely because right here is 2x dx. That's du. I've got a u under the radical. I've also got a u in this denominator here. So I'm accomplishing all sorts of things with this. So I get pi because, well, pi isn't part of any of this, times the square root of u minus 1 over u du. And when x is equal to 0, u is 0 squared plus 1, which is 1. When x is equal to 3, u is equal to 3 squared plus 1, which is 9 plus 1, which is 10. Great. I'm going to just rewrite this a little bit. I'll pull the pi out because I like to do that. Pi, integral from 1 to 10 of the square root of u, which is u to the 1/2, minus 1 over u du. I've been seeing a lot of people looking at 1 over u, writing it as u to the minus 1, and trying to apply the power rule to it. No, 1 over u doesn't fit into that. You'll notice if you try to use the power rule, you're divided by 0. Don't divide by 0. Instead, what we really should be getting is the natural log of the absolute value of u. Anyways, the power rule says change 1/2 to 3/2 on u to the 1/2, and then divide by the new power, which is the same as multiplying by its reciprocal, which is 2/3, minus the natural log of the absolute value of u. And this is going from 1 to 10. And then this becomes pi of, let's see, 2/3 times 10 to the 3/2 minus the natural log of 10 minus 2/3 of 1 to the 3/2 minus the natural log of 1. And at the end of the day, this is just going to be some weird looking number. I mean, 2/3, 10 to the 3/2, I have no idea what that is. Natural log of 10, again, I don't know what that is. 2/3 times 1 to the 3/2 is just 2/3, and log of 1 is 0, so I get this expression. It's worth your while to go ahead and say, is this actually going to be a number which is positive? Go ahead, check that. So here's question 2. Let's take this region, the region bounded between x equal to 1, x equal to 2, the function y equal to 1 over x, and the function y equal to e to the minus x squared. Rotate that around the y-axis and find the volume of the resulting solid. Alright. Do you sense a pattern here? Well, you should. The thing is, I've been doing this the whole time. You start with just a simple region bounded by a function, x-axis, and two lines. Then it's a function and the x-axis. You have to find points of intersection. Then it's two functions and two lines that are given to you. Now it's just two functions, and we have to find the limits. And the limits are going to be given by the points of intersection of these two functions, because the entire region lies between this point and this point. So we're taking this region bounded by x squared minus 8x plus 20 and negative x squared plus 6x, and we're rotating around the y-axis. So the first thing I need to do is set them equal to find what these points are to get my limits. X squared minus 8x plus 20 is equal to negative x squared plus 6x. I add x squared to both sides, 2x squared, subtract 6x from both sides, minus 14x plus 20 is equal to 0. Divide everybody by 2. X squared minus 7x plus 10 is equal to 0. And this factors as x minus 2 times x minus 5 is equal to 0. So this tells us that x is equal to 2 or x is equal to 5. Great. So this must be the number 2 here. This must be the number 5 here. That's all we really need to know. Okay, so the volume is going to be the integral from 2 to 5 of 2 pi x times the difference between the two functions. It's going to be the top function minus the bottom function. Why is this the top function? Look, its graph is on top on the region that we care about. This guy is on the bottom on the region we care about. So it's going to be that times negative x squared plus 6x minus, I'm running out of room, so minus x squared minus 8x plus 20 dx. And this is going to give me 2 pi x times. One of the nice things in this sort of problem is that this subtraction has already sort of been done for you. When I solved over here, I got everybody onto one side. In effect, what I got was x squared minus 8x plus 20 minus negative x squared plus 6x. I want the negative of that, so this is negative x squared plus 7x minus 10 dx. I'm going to multiply through here, nothing fancy. Let me pull out the 2 pi just because. So 2 pi integral from 2 to 5 of negative x cubed plus 7x squared minus 10x dx, and then I integrate. This becomes 2 pi times negative x to the 4 over 4 plus 7/3 x cubed minus 5x squared from 2 to 5. And at this point, I'm going to say, you can just plug in, get your answer. Great.